Hello class, it's Mr. Kablan here again, and today I'll be presenting the second lesson for chapter 6, which is going to be dealing with the key features of quadratic relations. Just to do a quick recap of what we did in the last lesson, you learned the difference between a linear relationship and a nonlinear relationship, and you discovered that in a nonlinear relationship, you learned how to draw what was called a parabola, which is a U-shaped curve that either opened up, and today you're going to see what a parabola is when it opens down. So if you take a look at today's lesson over here, let's get this started right away. So today, like I said, today's topic will be the features of quadratic relations. Now, today's lesson is going to involve a lot of new terminology. So if there's any new words that you see over there, just make a note of it because they are going to be important words that we'll be looking at, not just in this chapter, but the next two chapters as well. All right, let's take a look at this lesson here. So if you take a look at the screen over here, you notice there are three graphs. Okay, we have, starting from the top left, we have this graph over here, this graph over here, and this graph over here. And we're going to use these three graphs over here to explain exactly what the different parts of a quadratic relation is. So remember from the previous lesson, any quadratic relation is given in the form, given an equation in the form of y equals ax squared plus bx plus c. And just as a reminder that anytime you see the exponent 2 attached to the letter x, that tells you right away that what you have there is indeed a quadratic relation. Now, what we're going to look at in today, if you look at the letters attached to the x's, we're going to focus part of today's lesson on the letter a. Now, what the letter A is, it can be one of two things. It's either positive or negative. Now, what's important here is exactly what information that particular number tells us for the graphs that you see on the screen. So it tells us here if the A value is positive, for example, positive 1, positive 2, positive 3, even something like positive 0.5. Okay, this tells us that we have a parabola that opens up and has what's called a minimum value. Now, the part that's confusing sometimes, people ask, well, how do we know if a parabola is opening up? When you take a look at the parabola, okay, if it's in the shape of a U and there's two arrows that are pointing upwards, okay, that's an example of a parabola that's opening up. So if you take a look at the three graphs that you see on the screen over here, that means the first graph and the second graph, these two would be examples of parabolas that are opening upwards. Okay, take a look at them. Again, both are in the shape of a U, and notice that both graphs here have arrows pointing upwards. Another quick shortcut for this is if you take a look at the arrows, if they're pointing up, okay, that means that that the parabola is opening upwards. Okay, that's probably the easiest way to do it. Now, the opposite of that is when the A is negative. Now, when the A is negative, it tells us that the parabola is opening downwards. And as you can see, the one at the very bottom here, that would be an example of that. So any parabola that opens downwards, okay, you have an upside down U, and you notice the arrows here are also pointing downwards. So the next important thing here is this word called the vertex. Now, I'm not going to read this whole definition because it doesn't really make sense. It's straight from it's just straight from the textbook definition, which is fine. However, the quickest way to locate where the vertex is, it's the dead center of the parabola. So if you take a look at this first one over here, I'm going to represent them with a red dot, and feel free to do it on your notes as well. So for example, for the first graph, this red dot, that would be a vertex. On the second one here, that would be this point over here. And last but not least, that would be this point over here on the last graph. Okay, so when you're looking at a parabola, okay, where the U changes a direction, okay, or the middle of the parabola, that's exactly where the vertex is. And in the next lesson, you're going to see that that vertex, believe it or not, happens to be one of the most important features of a quadratic relation. In fact, you're going to see a preview of that in today's lesson as well. All right, now, with the vertex, as I said a few seconds ago, it does tell us something that is very important, which is called the maximum or minimum value. Now, depending on which direction the parabola opens, okay, you either have a maximum or a minimum value, and again, it's dependent on the opening of the direction. And we're going to look at some examples to make you to reinforce that particular set of knowledge skills. All right. Okay, now this next thing over here is what's called the axis of symmetry. Now, going back to the previous slide over here, notice that we put red dots on our vertexes or vertices. So that helps us for the next one, because what the axis of symmetry is, it's a line that cuts through that point that you should have drawn on your graphs there. So if you, basically what happens with the axis of symmetry, okay, it cuts through the dead center of the parabola. Okay, and the axis of symmetry itself has an equation. So basically, a quick way to look at that is when you draw the line, and you're going to see in this first example, okay, notice that this line is cutting through straight downwards like so, as you can see in the red dotted line there. Now, the equation of the axis of symmetry can be located in two different ways. Okay, you can either look at the x-coordinate of the vertex, or if you're going to look at the axis of symmetry, you can see where it crosses the x-axis. So as it goes down, you notice it crosses the x-axis at 0. Well, guess what? That happens to be the equation of that particular line there. So that's why the equation of this red line that I've drawn here would be x is equal to 0. Now, when it comes to equations for axis of symmetry, this is the only line that does have an equation that is represented by the letter x. Okay, if you take a look at the second graph, I'm going to draw a line that cuts through the center. So notice that I've drawn a red line straight through, and you notice it crosses and touches the x-axis at 3. That's why this red line here will have an equation of x is equal to 3. And this one down here, you're going to see I'm going to draw a line straight through it, and it's going to cut through the x-axis, okay, at -1. So again, a couple ways, like I said, in terms of figuring out where the axis, what the equation of the axis of symmetry is. Again, it's where the line touches or crosses the x-axis, and you can see that in the 3 examples that I've done here. All right, let's take a look at some new examples. We're going to put all that together. And before we do that, actually, we want to talk about what x-intercepts are. And what x-intercepts represent is where the curves, all 3 of them, touch the x-axis. Now, the reason why I have these 3 graphs in particular, because each one of these represents the 3 cases in terms of how many times a parabola touches the x-axis. And there are only 3 possibilities. Okay, they can either have no x-intercepts, 1 x-intercept intercepts, or 2 x-intercepts. So an example of 0 x-intercepts is this one over here, the first one. Because you notice that this curve over here does not touch the x-axis in any other way. So this one over here will have no x-intercepts. Now, if you take a look at the remaining 2, okay, ask yourself again, now which of the 2 graphs here touches the x-axis once? Well, if you take a look at this last one over here, the one at the very bottom, this one only touches the x-axis at 1 point. So this here would be an example of one that touches the x-axis at 1 spot, which would make this 1 x-intercept. And that would make this, the remaining one, 2 x-intercepts. Because as you can see in this one over here, okay, this curve, okay, goes up and then comes back, goes down, comes back up, and it touches the x-axis at 2 points, at 2 and 4 in this case. So that's an example of 2 x-intercepts. All right, now that I know it's a lot of terminology now, so let's actually apply it now. So let's take a look at some examples. So what we want to do for this one, again, is just to take a look at the graph and identify the following here based just on this graph over here, okay? And believe it or not, we're just going to use our eyes to figure that out. So question number 1, it says identify the coordinates of the vertex. Now recall from the first slide, all the vertex is the center of the parabola. So if you take a look at this parabola over here, okay, notice the center is right there. So I'm going to represent that with a red dot, okay? And it does help you to see where that is. Now remember, when you're looking at the coordinates of a vertex or a point, or any point for that matter, you always have to state the 2 numbers, which are the x and the y coordinate. So if you take a look at the location of this red dot, starting from the center, I'm going to go left 1 and then down 4. So the coordinates of this vertex here will be -1, -4. Now, I stated at the beginning of this lesson here that these 2 numbers over here are very important numbers for the remaining set of the questions. And I'm going to show you that once you have the vertex, okay, it's going to make it easier to answer the following questions in this one question that we're looking at. All right, the next one we're going to look at here is the equation of axis of symmetry. And remember, we did this in the last example, is that all you have to do with the axis of symmetry, and it's not a little bit easier now that we've plotted the vertex, is we're going to draw a straight line that cuts through that point that you see. So if you throw a ruler down and you put it through your red dot there, okay, I'm going to cut a line that looks like this. Now, as you can see here, when you're looking at the equation of axis of symmetry, okay, I mentioned earlier in this lesson that there's actually two ways to determine the equation of axis of symmetry. Okay, if you're a visual person like many people out there, you can see that if you take a look at this line, okay, and you see where it touches the x-axis, okay, that will be the equation of this line here. So in this case over here, you can see that the the axis of symmetry touches the x-axis at -1. So the equation of the axis of symmetry is going to be x is equal to -1. Now, another way you can do this, and let's just say you didn't get a graph, and believe it or not, there's going to be some cases where you won't be getting a graph. If you take a look at the vertex, okay, you notice that there's a -1 in the x coordinate of the vertex. So if you didn't have a graph and you're wondering what the equation of the axis of symmetry is, okay, just look at this point over here, which I'm going to highlight here in red. Okay, notice that we have a -1 as part of the coordinates of the vertex there. Okay, so this here and this here are exactly the same thing. So now you have two ways to determine what the axis of symmetry is. All right, moving on. Next thing we're going to do here is a y-intercept. Now, if this sounds familiar to you, okay, it really is because you spent a lot of time in grade 9, and we did it in the first chapter in this course. Now, the definition of y-intercept is where the curve touches the y-axis. So going back to the diagram, if you take a look at the parabola over here, okay, and you see where the line touches the y-axis, which is right there, okay, I'm going to represent that with a yellow dot. Now, where this yellow dot touches the y-axis, that's going to be the y-intercept. So you can see here that this yellow dot here touches the y-axis at, well, -3. So guess what? That is the y-intercept. All right, so right now what I want you to see here is I want you to see now that we've located the vertex. From the vertex, or by looking at the line, we have the axis of symmetry. Okay, we've also just used our eyes for the time being to figure out the y-intercept. As you can see here, it touches the y-axis at -3. Now, for questions 4 and 5, we're now going to find out a way we can use the vertex again to figure out what these answers are. So for part A, or sorry, 4A here, it says, is it a minimum or maximum? Okay, and I'm going to break this question into two parts so you can understand exactly how to figure that out. Now, the first thing we want to do here is, well, let's look back at the curve again. Now, you notice what we have here is a curve that opens upwards. So, well, the parabola opens up. Now, what you need to know is that when a parabola opens up and you're trying to figure out, well, how do we know if something's a minimum or maximum? Okay, quick way to remember this is the fact that when you're thinking about the word minimum, okay, you're thinking about something that is lower or the lowest value possible. Well, for this particular example over here, you're basically looking at the very bottom part of this parabola. Okay, so in this case here, what we have here is an example of a minimum. Now, I mentioned not too long ago is that the vertex actually tells us another important piece of information over here that's going to help us answer the rest of these questions here. So for the next part here is what is the value? Now, if you take a look at the vertex, all you need to do for this one is to take a look at this value over here, which in this case here is -4. Now, the -4, again, that's going to be the value of the minimum, okay? And that's pretty much it. So notice I've circled there in blue where you can find that. And as I said before, this is why it's important for you to find the vertex first, because the vertex helps you determine the axis of symmetry based on the x coordinate and the minimum or maximum value from the y coordinate. All right. And last but not least here, it says how many x-intercepts are there. So if you take a look at this diagram here, okay, you can see that we have a parabola that touches the x-axis at 2 points, right here, okay, and right here in green. Okay, so there are 2. So in this case here, we have an example of a parabola that touches the x-axis at 2 different points. Okay, and the 2 points here are respectively x equals -2 and x is equal to 1. All right, so now that you've seen this, okay, I want you to pause this video and I want you to try the next question and see if you can come up with the correct answers. Take a moment to do that. Press pause. All right, I hope you got to fill out this one over here and double check your answers with what I'm about to present to you. All right, so it says identify the coordinates of the vertex. Now, before we begin, just to double check over here, notice that this graph here is an example of a parabola opening up. We now have an example of a parabola that's opening downwards, all right? Okay, identify the coordinates of the vertex. Now, remember the vertex is the dead center of the parabola, so I'm going to represent that with a red dot just like that. And remember the coordinates of the vertex consist of 2 points, an x coordinate and a y coordinate. So if you carefully look at this, okay, you notice that this is the point here. So we have an x coordinate of 1 and a y coordinate of 8. Now you're probably wondering, should we find the vertex first? Okay, the answer to that is yes, simply because, as we did in the previous example, these two numbers are going to be important numbers for the remainder of the question, all right? Okay, moving forward, it says the equation of axis of symmetry. Again, we're going to do this both ways, just like we did in the previous example. So I'm going to draw a straight line that cuts through the center just like this. All right, now once I cut this straight line over here, notice that as I go down, it touches the y-axis at 1. So the equation of this red line here is going to be x is equal to 1. Now, remember in the previous example, I also showed you another way to figure out what the equation of axis of symmetry is, and it's simply by looking at the x-coordinate of the vertex. So you notice I'm just circling the 1 over here, and you can see it's exactly the same thing as that. All right? So again, when you're looking at the axis of symmetry, again, 2 ways to do it. You can either draw the line and see where it touches the x-axis, or you can simply just look at the x-coordinate of the vertex. All right, the y-intercept. Okay, the y-intercept, we're just going to use our eyes to find that one. So if you look at this curve over here, just ask yourself, where does this curve touch the y-axis? Well, as you can see, and if you follow along over here, this curve touches the y-axis right there. Okay, I've labeled in the yellow, and it touches the y-axis at 6. Okay, nothing else to that. All right. Questions 4A and B, we want to figure out if something is a minimum or maximum. So as I said a few seconds ago, this parabola here opens downwards. Now, for this one over here, okay, determine whether something is a minimum or maximum, okay, you're always going to look at the fact, well, since the parabola opens down, think of a mountain. Okay, when you reach the maximum height of a mountain, you're thinking about the top. And that's exactly what we have in this example. So that's why anytime you say parabola that's opening downwards, this is going to give us a maximum, all right? So that's going to be that. Now, for the value of the maximum, again, going back to the importance of finding the vertex first, okay, notice the easiest way to do that is to figure out what the y-coordinate of the vertex is, which in this case here, as you can see, is the 8. Okay, so now that we have that, this 8 will transfer over down here. Okay, and that's why the answer to this answer is just going to be y equals 8. All right, and last but not least for this one over here, okay, it says how many x-intercepts? Well, if you take a look at the graph again, okay, it touches the x-axis at 2 parts, or 2 points, specifically over here and over here. Now, in terms of the x-intercepts, again, it's just where they cross the x-axis. So in this case, it's going to be x equals -1 and x equals 3. All right. So again, just to recap, always find the vertex first. Okay, the axis of symmetry can be determined by looking at where the line touches the x-axis, or by looking at the x-coordinate of the vertex. Now, since this is a parabola that opens downwards, okay, what we have here is a maximum, and the value of the maximum can be found by the y-coordinate of the vertex. All right, moving along here to the final example. Okay, we're now going to look at an equation and use that equation to complete the table of values. So basically what we're going to do in this example is just now going to be a combination of completing a table of values, which we spent a lot of time on in when we're dealing with lines a couple of chapters ago, as well as what we did in the previous examples. Now, what I'm going to do here again is just to show you how you can put this in your calculator so you can figure everything out in one single step. Now, what we're going to do with each of these x values is to substitute them into the equation that was given to us in the question. Now, again, when you're doing this in your calculator, carefully put it in, because remember I always say in class, calculators never give wrong answers. The way you get wrong answers is you just simply put them in the calculator incorrectly. So when I put the -2 in for the x, remember that when you replace a letter with a number, you always have to put brackets around it. And as long as you put this correctly, you should get a value here of 11. All right, same thing with a -1. Okay, notice I've just put a -1 for the x here and put brackets around each one over here. So if you did that correctly, you should get 6. Okay, and for 0, okay, you should get there a value of 3. All right, now feel free to pause this video now to take a look at the steps here. But again, these steps on the side here are only necessary if you actually need to do the calculations. If you're good with your calculator, just plug it in. Just make sure you get the same answers I'm getting here. All right, to finish off the table over here, let's take a look at this one. So if you put in 1 for x, you should get 2. And if you put in 2 for x, okay, you should get 3. So what we're going to do for this, as you're completing this over here, we're now going to take a look at each of these and express them as an ordered pair. And we're going to plot them just like we did in the every time we plotted points. So we're going to represent these each as an ordered pair so you can see exactly how we can graph these using what we have in this table. All right, so starting off with the first one, we have the point -2, 11. So remember, we can do this because remember the x coordinate tells us which direction to go left and right. Okay, and the second number tells us which direction to go up or down. Now to plot the point -2, 11 from the center, we're going to go left 2 and up 11. Okay, for -1 and 6, we're going to go left 1 and then up 6. And then we're going to go 0 and 3. All right, so notice we've looked at the first 3 points over here. Now we're going to plot the next 2, and you're going to see something that's a little bit different for this one. Okay, so what we have here is 1 and 2. And last but not least, we have 2 and 3. Now you notice this last point, it goes back up here, and you're probably thinking, well, is that a mistake? Well, no, because what we have here is an example of a parabola. So you're going to connect these 5 points here with a smooth curve like this, all right? And don't forget to put arrows at the end as well, just to remind yourself that this is a parabola that opens upwards. All right, moving along. Okay, just like we did in the previous 2 examples, we're going to do the exact same for these ones. So identify the coordinates of the vertex. Well, we don't need to draw the point here because it's already there for us. So remember that the vertex, okay, is the dead center of the parabola. So as you can see, it's this one over here. So that's going to be 1 and 2. All right, now, as I said before, you identify the vertex first because it helps us figure out what the axis of symmetry and the maximum and minimum value is. So remember, the axis of symmetry can be determined in 2 different ways. Okay, one of the first ways, and people like to use their eyes for this one, is to simply draw a line through the center. Okay, and you can see that this line crosses the x-axis at 1. So this line over here is going to have an axis of symmetry of x is equal to 1. All right, the y-intercept, again, take a look at where the curve touches the y-axis. And as you scroll along, you notice it touches the y-axis at 3. All right, and since we have a parabola that opens upwards, okay, what we have here is another example of a minimum. Okay, again, just another quick way to remind yourself, what is a minimum? Okay, think of the bare minimum, which is actually the lowest point. Okay, and the value of that can be determined by the y-coordinate of the vertex, okay, which is y equals 2. And let me just quickly highlight that again. Again, the axis of symmetry can be determined by either drawing the line or by looking at the x-coordinate of the vertex like so. Okay, in a similar fashion, okay, you can also use the coordinates of the vertex to determine the minimum or maximum value. Well, in this case, it's a minimum value. So if you take a look at this, the 2 over here, same thing as this. All right. So again, please make sure that you can see where how the vertex is very important to determine the rest of the answer to this question here. All right. Okay, last but not least here says how many x-intercepts? Now remember, the x-intercept is where the curve touches the x-axis. Now this is not a trick question because, believe it or not, you're probably looking at this curve and saying, well, it doesn't touch the x-axis. And guess what? You're absolutely right. Okay, it doesn't touch the x-axis at all. Now, since it doesn't touch the x-axis, okay, there are no x-intercepts. All right, that wraps up today's lesson. Again, continue working on with the review. And again, I'll see you in the next lesson.